Hello friends, so this is Reshma. I welcomes you again to DBMS session, and in today's session we'll discuss about alternative notation for ER diagram. In previous session I have discussed about the construction of ER diagram using different notations, using different symbols of basic ER diagram design. So today I discuss about the alternative notations used for the construction of ER diagram. So here the alternative notation is using min-max method. So where this min-max method are used to represent participation constraints and cardinality constraints. Here the value of min, if it is 0, which indicates partial participation, and if value of min is greater than 0, used to indicate total participation. And based on the value of max, we can specify cardinality constraints from 0 to n. So now if we consider some example like a works for relationship between employee and dependent department with n is to 1 constraints which are having total participation for each entity. So now in the alternative notation using min-max method, we can rewrite as below. So that is here between employee and works for, I have total participation. So min value is 1. Again between works for and department, we have total participation. So min value is 1 here also. Now if I go for the value of max, I need to take from opposite relation. So that is between employee and works for, the max value will be derived from cardinality constraints between works for and department. So between works for and department, I have cardinality constraint as 1. That 1 should becomes max value between employee and works for. In the same way, max value between works for and department is extracted from the opposite order, that is employee and works for. So between employee and works for, I have cardinality constraints as n that I need to copy for max between works for and department. So this is a simple example where we have converted cardinality and participation constraint representation using min-max method. If I take one more example, that is dependence of relation between employee and dependent. So here min-max notation is between employee and dependents of value of min is 0 because I have partial participation, and between dependents of one dependent it is 1, so because I have total participation. So now to copy cardinality constraints, right side n becomes max value for left side, and left side 1 becomes max value for right side, that is between dependence of one dependent. So this is a second example. So like this we can convert the basic representation to min-max method. So then this is the ER diagram which we have constructed. So now we can replace cardinality and participation constraints to min-max method as shown here. So now we'll discuss some other concepts of ER diagram, that is we'll begin with generalization. So the generalization, this is a bottom-up approach. So where two or more entities at the lower level they will be combined and they will form a higher level single entity. Two or more entities at the bottom will be combined and it will form higher level entity. And this combination can be done if they have same attributes. And again, the entities at the higher level, they can be further combined and they can form next higher level entities. So we can say the generalization is just like a subclass and superclass concept. But the difference is the approach which we are using here. So you can say the generalization, it uses the bottom-up approach. That is a different set of subclasses will be combined and they will form a super class. See, for example, here, so faculty and student, they combined and they will form a generalized class person. So now here faculty and student, they'll be having the same property like name, age, birth date. Then such, if these two entities are having similar attributes, similar properties, we can combine them to a person. Similarly, if I take vehicles like bike, truck, car, all these can be combined and we can form a generalized class as vehicle. Then if I take one more example, if I take a specific department, CS, IS, EC, they can be combined and they can form courses like engineering. So this is the concept of generalization. So now if you go for specialization, so this is just opposite to generalization. Here the specialization is a top-down approach. That is, here one higher level entity can be broken down into two or more lower level entities. That is, super class can be subdivided into subclasses here. So that is, here first we need to define the superclasses and then subclass and its related attributes can be defined and we can form relationship between those subclasses in the next lower level. So specialization is a top-down approach. For example, here if I take an employee, the employee, he can be a tester or a developer. Similarly, if I take a vehicle, vehicle may be a car, it may be a train, or it may be a bike, it may be a bus. So that is, we'll convert higher level to the lower level. So these are examples for specialization which moves from top to bottom. The next is aggregation. So this is another method for the representation of ear diagram. So where we can make use of the aggregation concept. So now in aggregation, we can combine a relation between two entities as a single entity. So we'll be having two entity types and one relationship between those entity types. So now these entities and the relationship can be combined and it can be treated as a single entity. So that is, here relationship with these corresponding entities will be aggregated to next higher level entity. So for example, so here we have a relationship between center and course. So offer is relationship between center and course. So now what we can do, we can aggregate center offer for center and course into a single entity. And now we can say inquire is a relationship between the entity type visitor and the new entity type which is formed by combining center of a course. So now here, if I take this as real-time example, we can interpret this as first, before aggregation, if a visitor visits the coaching center, so then he will inquire about the courses. But if I combine center offers courses into single entity type, then we can interpret this as instead of inquiring the center about the course, so now he will inquire the both directly. So that is, he will inquire about both center and the course directly. That is, if a visitor visits coaching center, then he will inquire about the course if I have separate. But if I aggregate this, then the visitor can directly inquire about both the center and also the course. So this is an example for aggregation. Similarly, here we can see project works for employee, that is, employee works for some project, and whenever employee works for the project, he requires some machinery. So now what we can do, we can aggregate employee works for project as a single entity type. So directly we can say machinery is required for the entity which will be used by the employee to work on the project. So like this we can form aggregation. So these are some of the additional concepts for ER diagram, and here I have listed some of the standard ER diagrams which we can use along with the constraints on ternary relationships. And also sometimes if we have binary relationship and ternary or higher relationship, we can choose binary relationship from ternary. So now you see how to convert ternary to binary. Here I have a supply relationship as a ternary relationship between supplier, project and part, that is the supplier supply part for the project. So now we can rewrite this as binary relationship, so where we can have a relationship between every two entity types, like have can supply between part and supplier, supplies between supplier and project, users between project and part. So here single ternary relationship is converted into three binary relationships. So the second method is, so what we have done in the previous method, a single supply is converted to can supplies, supplies and users. But in second way, we can rewrite the supply relationship as an entity type supply. Then we can form relationship between supplier and supply, then supply and project, and part and supply. So these are the two ways for converting ternary or higher order relationship into binary relationship. So now using these concepts, here I have given some sample databases for different examples. So for hospital database, the ER diagram is given here. So here we have used all the concepts which you have studied, like aggregation, generalization and specialization. So another example for database is banking database system. So here we can see from four entity types, their attributes and relationship. The same way we have a library database management system. So these are the some of the sample ER diagrams and alternative notations. Okay, thank you for watching the video. And if you have subscribed to my channel, you'll be getting my next sessions. If not yet subscribed, please subscribe and click on the bell button so that you can get my next sessions. Okay, in the next session